Well, today, I was looking through on our internal chat stuff. Someone had, well, that someone is you. You had a request for like any input on slides or just going over it or something, and I was looking through them, and I was thinking these look great. I should get a recording of these, primarily also so that I can learn what's in this stuff. That's always a good way of going about things. But before we get to it, why don't you introduce yourself?
Hello, everyone. My name is Gregory Green. I am a solution architect focusing on our Tanzu data products, and I'm just on it and excited to go through this talk.
Yeah. So what I'm looking forward to personally is you've got a good introduction to AI versus ML and models, all the terms, which I still think is well for me, but in general valuable for people to go over because these terms get thrown around a lot, and I think the distinction between ML and AI will be interesting to go through, and then also some kind of analysis in there, and then I think not some kind of analysis that you're doing of the topic, but how you use these things for analysis. and and then also I think the second half of it is doing something with it, particularly like by using Spring as a way of just kind of figuring out how to do something with all this AI stuff, which will be interesting to see. Plus, you'll hopefully finally give me an explanation of how vector databases and RAG and all that stuff works, because I've listened to it and it sounds like I get kind of the same reaction when I hear about encryption, and I'm just like, math. I'd like to know more, other than
Awesome.
complicated equations. So, with that, why don't we launch into it? Why don't you kind of start going through this, and if some questions come up that I have, I'll interject here and there.
One of my motivations for doing this conversation is because I had the same struggles. People were throwing out all of these terms like AI and ML, and I just couldn't get it. So it clicked to me. So I started writing it down in ways that it's easier for me to understand. So I hope the audience will be able to benefit from this. This talk on unlocking real-time AI ML was given just last week at an awesome conference called Afrotech in Houston, Texas. And in here, basically, I'm explaining what here is the let's go through the slides. So here's the content that's in this. So like to level set on what we mean by AI and ML. We'll go through some terminologies and talk about some of my absolutely favorite technologies like Spring and data services. These are technologies that I really have the honor and privilege to working with and advocating its use for companies throughout the Americas. Also talking about some architectural principles that just make it easier to deploy these types of solutions anywhere before wrapping it up. And this is really the goal that I want everyone to walk away with a better understanding to the answer to this question after this conversation. And I think that this question is kind of like it's like a universal business use case on how we can understand information to make informed decisions. But most importantly, the key in this is how do we make it quicker? And the use case, I always like to do use cases. So it's better to understand a particular technology by focusing on how it can be used in some sort of context to solve a particular problem. So the context of this is natural language processing, right? And I get involved with companies that have just lots of data, right? So, for example, there are certain organizations that get data feeds from social media outlets, from emails, customer surveys, product feedback forms, so on and so forth, right? So, really, you can get overwhelmed with information, and it's lots of good information, but it's just a massive amount of it. So how can, again, without somebody manually reading through this information, I think it would be good to be able to pull out certain things about text. Like, for example, is this information, this message, is the outcome of it, is it good or bad? Is it real? Is this an actual person that's sent this feedback form or sent this email? Or is it some automated process out there? Or can it be potentially dangerous, right, in some way, shape, or form? So again, without reading through the context of all of those messages at scale, artificial intelligence can help to answer each one of those questions. And again, just to level set, what I mean by AI is it's basically just technology, right? It's just a combination of software and hardware. But most importantly, it emulates or acts like or emulates human intelligence, meaning it's able to learn, right? So AI is not new, right? It's been in software and in applications for a really, really long time. But there's some newer concepts that we're trying to introduce into the AI space. One is ML, right? So machine learning. So machine learning is a classification of artificial intelligence, right? But it uses math, like you said, Michael. At the end of the day, it just uses mathematical algorithms to solve a particular problem. So going back to those questions that I highlighted previously, whether you want to determine in an automated fashion whether some information is good or bad, well, that's called, in the AI space, that's called sentiment analysis. And whether it's real, that can be fraud detection, and whether it's dangerous, that could be threat detection. So again, AI and ML can be used to help us to do really cool things, but the way it does these things is at the core of ML is something called a model. So a model or a machine learning model, at the end of the day, it's just a file. It's a binary file, and it's the way it's formatted. It's formatted almost like an embedded algorithm, and you produce these files or these algorithms based on a process called training, right? So once you train it, you produce the file, you provide it some input, and it's going to produce some output based on the data that it was trained with. And there's all different ways that you train the data, or that in another way to say that is ways that the model learns, right? It learns based on the training. So there is a supervised training, and then the terms underneath there, underneath the boxes, are the specific algorithms or the ways that you train the model. So again, supervised training is basically some human preparing data that has inputs, and then it tells the model when you have this inputs, this is the expected output, right? And then you have unsupervised training. That's really cool. That's really where the models, you just give the models some data, and the models just figure out the patterns in that data without any human intervention. And then you have reinforcement training. That's sort of a combination of humans and the model learning itself. The way I like to understand it is like, do you have a pet?
Oh, yes. I unfortunately have too many pets. Got a
Okay.
dog, 2 snakes, a cat, and turtle, and a suckerfish.
Okay.
And then also kids.
Okay. So going back to the dog or the little puppy, right? What's your puppy's name?
It's Junebug.
Junebug. Okay. So you do reinforcement training to Junebug, right? So when Junebug does something good, you reward good behavior, and when they don't do, little Junebug does something naughty, right? You basically don't reward that behavior. And that's the same way with models. So when a model produces an output, a person will say, "Hey, that's correct," versus "This is not correct," and it learns based on the consistent training or the feedback that a user gives to the model. So, and this slide kind of sums up. This is just a subcategory of the many cool things that you can do with models. So, for example, classification. Now, I'm going to walk you through an example of doing classification. So classification is basically just when data comes in, you just determine what that data is based on the training data, right? Anomalies. Anomaly detection, it's just as the name implies, right? So I like to use the example of, for example, with the speed limit within a certain neighborhood, right? most cars are maybe within 15, 20 miles per hour of that limit, right? So when you got something that goes like way outside of the norm, like 100 miles per hour, 200 miles per hour, right? In automated ways, models can determine those trends outside of the norms. Anomaly detection is really good for also fraud detection, because if the models has a user's data set, they'll know the typical range, their typical spending habits within certain periods. So when their spending habits goes outside of the norms, that's when you'll get those messages to say, hey, was this really you? We noticed some suspicious activity, so on and so forth. Regression is sort of like predicting the output of something. Like, for example, predicting the outcome of the price of food in the supermarket, or the price that you would sell your house, so on and so forth. And the other one I want to highlight is something called clustering. So clustering is a way for models. There's some models that, for example, you give it a whole bunch of data, it's able to organize that data based on similar properties. So for example, if somehow you have given it a whole bunch of images, it'll know that these group of images, or like humans, will be much different than puppies, for example. Again, based on just converting that data to the mathematical formats and just looking at the trends in that data. So it turns out that, again, going back to those original asks for AIs and ways it can help, all of these, whether sentiment analysis, fraud detection, and threat detection, they're actually all classifications within the classification space of AI ML. And so one more term, just again, this is just a level set on the terminology. There's something called inferencing. So inferencing is basically just using the model. That's all it is. It's basically incorporating the use of that model within the software. Some application written in some programming language. It will receive input maybe from a user, maybe from a downstream system, and it will pass that data to the model. The model produces an output that the application again uses and massages and all of that stuff to provide some output. That whole process is called inferencing. All right, so those are the terms. Now we're going to build on these terms to work on some things. So again, going back to how the model is trained. So this is some details. This is an example of how you would train a model. So in this case, I'm training the sentiment for some data. So if I give it some descriptions to say, I love this particular TV show, or if somebody's complaining about the price of something, like for example, the prices of groceries, it's just crazy. The price to get the price to get juice and just a bag of chips from the airport, it's like you could easily spend like $10 on two things, right? So I could teach the model that all of these things are either negative or positive. So the more data I give it, the more it's able to, even if it wasn't trained on the specific terms, if it sees something similar to what it was trained, it will provide that output with some probability of how accurate it thinks it is, right? Based on what it was trained on. So those examples are, the previous slide is an example. I can probably train like a small model by giving it some data on my local laptop. I've done that before a couple of times. But then there's something called large language models, right? So large language models, they go through the same process where they're trained, but they're trained on massive amounts of data, right? So think about like data, all of the data that can potentially use that is on the public internet, right? So those types of models are not something that I would train on my local laptop, right? I need massive amounts of infrastructure in order to, first of all, aggregate the data and to go through the training process, right? So large language models, they could actually do multiple things, right? They may not just do classification. They may not just do anomaly detection, so on and so forth, right? They could do many different things because they have so much data that's built into them, incorporated into them. But the cool thing is that me as a developer, I actually don't need to train a model. For it depends on the use case. There might be some use cases that I absolutely need to train the models, but there are publicly available models that we can incorporate within our applications. Like, for example, OpenAI, right? Most people are very familiar with OpenAI or ChatGPT, right? And I think that that's really related to the explosion and the excitement of AI in the AI space, right? OpenAI basically just put a really easy to use interface on top of a model, the GPT model, right? And that's something called generative AI, where it actually does creation in the back end. Like, it actually thinks to actually solve or produce new ideas based on input. But again, it's just based on training data, and it could do unsupervised training, right? So the more data you give it, the more creative it can be, and the better it is over time, right? That's really that's really an exciting space. The other thing is, right, so ChatGPT you can use, and it's a price, and it's limited free usage, but we really want to use it intensely, it's going to be a price associated with it. Now, there are free models that have been just donated to the community, like Hugging Face is one example, where it's just a repository of models that have been donated by various different companies. They give really an easy way for you to consume those models within the application. Again, you don't have to train them. They're basically just available for you to just use. So now we got that context. So what I did, well, when my talk got accepted for Afrotech, and I'm such a huge fan of that conference, I was so excited. I ran out and I built an example AI ML application. And this is an example, and this is a screenshot of the application. And this is the QR code. You can actually download the code and start using it yourself. But basically, it does sentiment analysis, and it does real-time sentiment analysis. So meaning, as the data flows into the system, right, there'll be some processes that figures out the sentiment, so that when you display the message to the end user, again, without them having to read all of the context, it will just tell them offhand what's the sentiment of it, right? So for those people that are in a bad mood, right, and you don't want to, you just see negative sentiment, you can just delete it, right, without reading it. And this is the app running on my machine. So you see, I have I've been doing some testing before I did the call. So again, in real time, it's able to determine the sentiment of these messages. So for example, let's see, if I will send it a new message, let's see, I'll give it a message of a negative sentiment in the background. And
we've got to give some more encouragement about meatloaf. I think that's
yeah,
fantastic.
yeah. So I just sent this in the background, and again, it just determined the sentiment.
Nasty meatloaf. Oh, terrible.
Yeah. This daughter is she's relentless. Like she's free.
And look at she's
really
so nice afterwards too.
She looks so sweet, doesn't she?
She's got the classic American criticism. I hate this thing. Thanks for listening to me. Have a nice day.
Yes, yeah. So the model can figure out like, hey, this girl, she's free, right? She don't like meatloaf, right? So I think that's cool because as I go on, first of all, so again, trying to understand how this all works together. Remember, I mentioned how models are based on math, right? So at the end of the day, all of those messages, whether it's about meatloaf or this message, like I love my awesome wife, she is my best friend, all of that data needs to be converted to a mathematical format, right? So this is an example, and that's called a vector embedding. Again, at the end of the day, it's just numbers, right? So this is an array of floating point or double numbers, right? And the way you convert in this example, the text to the numerical format is, again, you can use a model. So, for example, in this application, I just used a model from Hugging Face that is basically able to take text, takes in text, and it produces the mathematical format or the embedding version of that text. And the way now that I have the numerical format of that text or the representation of that text, now if I wanted to perform a sentiment, I can also use another model, right? So there's other models within Hugging Face that do text classification, right? So again, if I give it that text version of the vector embedding, what it will provide me is an output. So for example, whether if the output, the number is below 0, guess what? That's a negative sentiment. If it's greater than 0, then it's positive sentiment. So this is where Spring AI really makes this all process super, super easy, right? So I would say the programming languages that dominate the space of AI ML, you'll see a lot of Python. You'll see the R programming language. Also C Sharp. C Sharp has been getting some more love and been popular in this space, in the AI ML space. But for Java, that's really been lagging behind, right? Having APIs that use within the Java space. But Java is so popular in terms of companies using it to build microservices and modern applications, right? So the Spring team, huge fan of the Spring team. They started to bridge the gap of bringing the AI ML capabilities into the Spring community with the Spring AI project, right? So what it allows you to do is, one thing it does is allows you to simplify inferencing, incorporating models from OpenAI or models from Hugging Face. So in my example, I'm using all models from Hugging Face. One thing that's also cool, I think, especially when you start talking about processing data in real time, is applications can always expose some sort of network-based interface, like an HTTP-based interface, right, to accept messages, right? But then you sometimes run into scalability issues, right? So especially when you think about like building a solution that handles massive amounts of inbound data, right? So maybe maybe thousands or millions of messages per day, or maybe even billions of messages in a day, right? Ultimately, you need a solution to be able to help that application to scale the processing of that data. And I always found that an event broker is the best way to handle ingestion or data movement. And of course, I am biased. I absolutely love RabbitMQ. It's my favorite messaging broker. And some of the reasons why I always advocate the use of RabbitMQ is because, again, the scale. So there are some newer technologies in Rabbit, and a lot of people are not aware about these newer features in Rabbit. So there's something called RabbitMQ Streams. So RabbitMQ Streams allows Rabbit, it's really an optimized, re-engineered new interface, a new protocol for Rabbit to receive messages or act as that buffering layer between applications. And it can scale to millions of messages per second. Some of the public benchmark numbers was about 17 million messages per second. But another thing that's cool about Rabbit, especially in the AI ML space, is you can use Rabbit as another source of truth. So for example, if you wanted to replay all of the messages so that you can update your model or train your messages based on the data that was sent over RabbitMQ, now you can do that with RabbitMQ Streams, right? So I can retrain those messages that talk about meatloaf, all them bad messages about meatloaf, and now you can update the model and say, hey, you know what? Previously there was lots of good sentiment, but now recently it's been all bad, right? instead of going back to like a system of record, for example, just replay those messages from a RabbitMQ stream. Another thing that's important that I needed for this solution is just some database to store my data. So I wanted to query data, for example. I can store all historical data in some sort of database. And my favorite relational database is Postgres, right? The reason, and this is one of the reasons I love Postgres is because, especially for the AI ML, it has extensions. So one extension is called Postgres ML. So Postgres ML actually allows you to actually do training and inferencing right inside of the database itself. So this is an example of doing inference for data, and it basically, you see, it's using text classification. It's using a text classification model. So what this is going to do is going to actually pull a model from Hugging Face into the database itself. And so when I query this out, again, the database did the inferencing for me, which I think is pretty cool, right? So I don't have to be an expert on R or Python or anything like that. As long as I know how to write a code to do a SQL operation, I can let the database do the inferencing for me and using a model. And so remember we talked about large language models, right? So large language models are trained on massive amounts of data, but a lot of that data is generic data, right? But if I wanted to teach the model about the context about my home, about your home, about a department, or about a company, what I would do is I can provide the context to the model at inferencing time. And what technique to do that is basically to use a vector database. So for example, this is an example, right? Like as you saw, Michael, right? So giving the model context about meatloaf, right? So, the husband is sending messages saying, hey, beautiful. Sending messages to the wife. Hey, beautiful, I love you. You're my best friend. But hey, I don't like meatloaf, okay? Can we just do something different? And, you saw what the daughter was saying, right? The daughter was like, I'm starting a petition against some meatloaf, like no more meatloaf, right? So what happens here is, let's suppose the son, right? If the son is saying something sarcastic, like, great, mom, meatloaf again? Well, it's very hard for like a model. Actually, models do not understand language. Remember, they're just doing algorithms, math, right? They understand numbers. So I'm converting everything to numbers and it's doing the math to try to correlate things, but it doesn't really understand language. Like, to understand sarcasm is something that's going to be hard for it to do. But again, if I give it more context, it can be able to better understand. Like, in the context of meatloaf, even though this statement by the son, it may seem positive, but actually it's negative, because everything that I see about mom and meatloaf is negative. So the model can say, hey, that's probably an inside joke. That's probably sarcasm. And I got an example of this. So what I'm going to do is on the home page, I can do a search. So I can search for meatloaf. And again, this is an example of doing a search. And what this is doing behind the scenes is doing a vector database search in Postgres. So again, every single thing about meatloaf is negative. See, it's all mostly the daughter, right? The son has one, right? So let me show you how we actually do this. So, yes. So again, Spring AI, one of the goals here is to make it super easy to use things like a vector database, right? To provide that context to those large language models, right? So this is the code in order to do a similarity search. See, again, I don't have to know like the low level details of doing like Postgres or SQL or things like that. This is actually an abstraction layer. So there are many different vector databases, right? Even in the Tanzu world, right? I support. We talked about Postgres doing as a vector database. There's also Gemfire can be used as a vector database, right? So if I wanted to swap out Postgres versus Gemfire to be used as a vector database within my Spring application, my code won't change, right? This abstraction won't change. My libraries under the covers would change, but again, it's just a way to just abstract to start using these vector database similarity searches to provide context to models. Yeah, and so the other thing is caching. So I think that especially when you talk about like the process to do the real time sentiment. So remember, I talked about like getting the text, converting the text to a number, right? Using a model, right? And then taking that output, using another model to convert that to the sentiment, right? And all of those, that whole process can take like a couple of seconds, right? It's not really it's not really fast. But in order to speed up things, right, you probably want to use a cache in some way, shape, or form, right? So a cache database is basically, there are in-memory databases that allow you to respond to requests really, really fast. I'm talking about like sub-milliseconds in many cases response times because the data is held in memory. So for example, instead of going through that entire process, when I get some message about meatloaf, I can ask the cache. I say, hey, did I get a message, the same message within the last day or so, or the last couple of hours or so? It can say yes. That's negative, right? And I can also evict the data. So I can say, hey, only keep the last couple of days worth of data. So for example, Michael, if the wife goes through cooking classes, right, and now she changed that sentiment, right, I want to expire that old data, because now maybe the daughter, even though she's a tough cookie, she might change her sentiment to say, okay, mom, good job. You're right. Now I like meatloaf. And this is sort of an example code of how you would introduce sort of caching. So for example, if I'm just searching for results by maybe the subject of a message, again, I can cache data. So if I get the same message, instead of going to Postgres and doing all of the queries, I could just return that really, really quickly from the in-memory database like Valkey. And this is an example of how I would set the expiration period of how long I want to save this data, right? So indicate seconds or days or however long I want to save that data. So does that make sense so far?
Yeah, and then I imagine with the caching, you can also use that for like performance controls and even cost controls. That if you're generally comfortable in our example here, if you're like the sentiment of meatloaf is stable, we don't need to go back and figure it out, right? You can just not even go back to the AI or database query thing and just return it from here, and then you don't have to run those queries.
Absolutely. So you save it on performance. You save it actually on the efficiency of your data centers, right? You're reducing the CPU consumption by just caching stuff in memory. So yeah, it's a super useful utility and use case. So this is the architecture all together, right? This is the processes that are running on my machine. So I have a couple of different Spring AI apps that do certain things. Some of them are basically they're basically processing, they're figuring out the sentiment in real time. They're caching data in Postgres into Valkey, and then I have, at the end of the day, I have some sort of user interface that exposes the UI to the users. So I think whenever you have sort of a solution like this, it's you probably want to be able to deploy this application or this solution anywhere, right? So the key to be able to deploy this solution anywhere, whether it's a public cloud like Google, Amazon, Microsoft's cloud, or private cloud, right? So here at VMware, right, in Tanzu space, we are the leaders in deploying solutions on the private cloud, right? So you can have that experience of easy provisioning your environment and scaling your environment on premise, right? I want to mention this is because a lot of companies, they're all in on I'm going, and we have an initiative that we're going to move to the public cloud. And then there are some companies that I've talked to, like they are a couple of years into that journey. They start seeing their bills at the end of the month, and they say, maybe we want to move to maybe another cloud that can give us a cheaper rate, or we want to move on premise, right? But no matter where you move your solution, what you want to do is you want to have a platform that just allows you to just easily move it anywhere, right? So the key to be able to easily move it anywhere is using platforms like our Cloud Foundry platform or just Kubernetes, right? So each one of those, where this platform again acts as an abstraction layer to simplify the deployment and the management of your applications and all of your data services. And the key to being able to deploy this solution on a cloud platform is to containerize everything, right? So again, most people understand what containers is, but again, for those of you who do not, I like to explain it as, think of it as a prepared package that has everything that you need in order to run that application or that data service, right? So like data services like RabbitMQ, for example, right? You have to install it on the OS. You have to configure the OS. You have to install additional runtime dependencies, like there's a runtime engine, and then on top of that, you install the binary, the RabbitMQ binaries, right? But what you could do is you can have a container that has all of those settings, the operating systems, the settings. It could be tuned. It can have best practices all, again, packaged together to simplify the deployment of the solution. And then in the RabbitMQ space, right, this is an example of container RabbitMQ to run on Kubernetes. So if I wanted to deploy a cluster of RabbitMQ brokers, a cluster is important because again, you want if you have a partial outage, let's suppose I say I want 3 brokers, right? Why I want 3 brokers? Because if something happens to one of them, I want it to be abstract to my applications that's either sending data to RabbitMQ or consuming data to RabbitMQ, right? So I can simplify the setup and the management of this all by basically providing the infrastructure, this file that will specify how many instances, give me a load balance endpoint. I can easily scale up my number of instances or give it more CPU power or more memory, all by just basically providing this text description of the environment to the platform. And at the end of the day, this is using something called an operator. That's basically an extension of Kubernetes that just makes it easier to manage Rabbit. All right. And so again, this is a picture of everything running together where all of the applications and the data services are running in containers, that provides that ease of management and scalability. We have our Spring applications that makes it easy to incorporate those models, I should say, those machine learning models, for example, from Hugging Face or OpenAI, and everything's running in containers. So my RabbitMQ, my Postgres, and my Valkey all running in containers. So yeah, that's pretty much the talk. So we're talking about how AI ML basically is using models to help us to make those informed decisions quickly. It's using models, which is just based on mathematical algorithms. We got Spring, which is making it easy to use models within the Java programming space. And we got data services like Rabbit and Postgres and Valkey that have specific, they bring different things to the table that make you easy to run, scale, and process the data in real time for this types of solutions. Questions, sir? Comments?
So I like the I don't know what you'd call it. Well, I think you did call it the reference architecture that you have, right? And it seems like I don't know. It's almost like what's everything that you need except the AI part to build an application on top of it, right? Which I think, and what's interesting, well, not one of the things that's interesting about what you went over is, I mean, in regular application programming, you want to modularize or componentize or whatever these things, and I can see how, especially when you're doing AI applications, it's very important to do that because you may not know the model that you're doing something with. You might have different caching things that you want to do. And then the other thing, which I haven't really thought about, is like the role of like all managing all the events that are coming in, right? And how that's a source of something as well. I don't know, but like what, I mean, can you speak to a little bit more of like these components and like how you could genericize them for whatever, not only for analyzing comments about meatloaf, but like how they might fit into different kind of applications or uses.
Yeah. And over the years, I've kind of just developed a style of programming, especially around whenever I think about real time, because one of the keys of this was like real time and inventing for data in general, right? Even independent of AI ML. What happens? What's a natural flow for designing solutions, especially when you start thinking about introducing event brokers, is separating concerns, right? So think about like a broker, a messaging broker in general, right? You're separating publishing concerns from consumer concerns,
right?
And then what happens here is it's almost like the CQRS pattern, which many people are very familiar with. It's the whole notion of separating query heavy operations from write heavy operations. And the reason why you do that is because you naturally be able to scale, right? You'll be able to scale your reads independently of your writes. When you start using brokers, again, it's the same idea. You can be able to scale your publishing side from your consuming side, right? So I'll go through a little bit details about like this particular architecture, right? So in this particular architecture, normally you would have some sort of application that is the source. It allows you to consume that data, right? And then ultimately it's pushing it to a RabbitMQ. Now, once it actually gets into the system, then you can start introducing like intermediate steps. So for example, in this case, the intermediate step is something called the event processor. That is the thing that does the sentiment analysis. But at the end of the day, when I want to evolve this solution, right? If I wanted to have more steps, so to be able to do more things, right? Ultimately, I just need to get the data into RabbitMQ. And if I want to have many more intermediate steps, I can be able to really, Rabbit allows me to future-proof this, to introduce new apps and new concerns and just string them together all using RabbitMQ. Now, the idea of the consumer here, the consumer, you could think of it as the end of the process, which is basically just a saves data, right? So, and again, this is sort of the write heavy pattern. So again, let's suppose this saves, you could have one that saves into Postgres and one that saves into Valkey. Let's suppose your Postgres, it can't handle millions of transactions per second, right? Most good databases, they're probably, I mean, if they don't, not talking about like NoSQL databases. I'm talking about like traditional relational database. They're hard to scale, right? You have to scale them vertically, meaning you traditional give them more CPU, more memory, so on and so forth, right? So again, you can have an app that's specialized on saving data to your database. And if your database is slow, again, the architecture itself can be able to can compensate for slow consumers, right? To be able to save that data in the rate that these data services can handle, right? And so again, in this case, this is saving to both Postgres and Valkey. But if I wanted to separate that out into two separate applications, I can very easily. You know why? Because everything's abstracted using RabbitMQ. So I think the key in kind of this is like, You have abstraction layers through messaging. Application, you can put as many applications and many process steps that you need, but the key is you can't do that if they're directly talking to each other. But you
Right.
can if you're using some sort of broker. And the application of the user interface, it's the same thing, right? So I can easily scale up to handle millions and millions of users, right? And this application, if it just wants to talk to Valkey or just wants to talk to the database, it can. It doesn't even need to talk to RabbitMQ. These applications, at the end of the day, they just need to get that data to my data services, right? But yeah, did I help?
Yeah, yeah. I mean, it seems like, you always learn as a, well, not always. Hopefully you learn as a programmer. You don't want to do a bunch of like premature optimization because then you're like optimizing but not shipping. But it seems like, what I like about reference architectures or basic architectures like this is it's almost like maybe there's a little bit of optimizing here, but it's not really that much effort to do it, and chances are very high you're going to need it. Not only for handling scale, but for a lot of the reasons that you were going over. So it's kind of like you might as well start with these like 3 separate swim lanes, if you will, rather than having, like you're saying, much more connected applications, because it's just going to give you plenty of flexibility and probably not really delay you at all, which is nice agility to have, I guess.
Yeah, I think absolutely. You hit the nail on the head. Don't solve problems that you don't have initially. But yeah, I think this was simple enough for me to separate out the concerns.
Yeah, well, that's great. I think that's a good overview, and especially as you can tell, the interest I had in how you actually build applications on top of it, right? Because I think that's probably where a lot of the work that most people will go and will be, right? Like instead of just starting from scratch with like training up a model and all that stuff, it's actually like, how do I get use out of this? And I think I think it'll be interesting to see like what kind of new application development patterns emerge from it. But I think there's probably a pretty good idea of the ones to start with, like you were going over.
Yeah. Hope so.
Yeah. Well, great. I mean, what as a last question. So when you kind of go over these ideas with people, when you're talking about the architectures that they're having, like what type of stuff are they? I don't know. How are they figuring this out? Like, how are people kind of going through a process of like, I want to use AI for something, and then what do they do next? like what's the process they use to actually get to something useful with it?
Yeah, I mean, I would say, honestly, a lot of companies are just struggling to figure out how to use AI, right? It's just a lot, just been a lot of hype. There's a lot of fear actually. Like people, they don't know, they're not using it. They don't know how to use it, but they feel like if I don't start using it, I'm going to be like the blockbuster videos of the world, right? Just become a dinosaur, right? But I think the first step of any AI is basically is connecting data, right? You can't really use AI or machine learning, right? It's all based on data, right? So, building out feature stores, building out cache and stuff like that, you've got to start with the data itself, right? So I see a lot of companies, again, they are exploring data orchestration solutions. Like, for example, I didn't really call it out in this talk, but this architecture is really inspired by one of my favorite Spring projects, which is basically it's called Spring Cloud Data Flow. Spring Cloud Data Flow is basically a way for you to use out-of-the-box components that to do ingestion. So there's out-of-the-box source applications. So, for example, if you want to put an API to expose an API to receive data, whatever the data is generically, and to be able to again save that data to a database. Again, instead of writing things by scratch or from scratch, I should say, you could basically just use these out of the box applications. So again, I think the first step is like building those data integration services, exploring platforms like Spring Cloud Dataflow that just makes it easy to start incorporating or start building out these data integrations. And then the next part is then starting to explore Spring AI, OpenAI, Hugging Face, so on and so forth.
Yeah, yeah, and I guess pun intended. Like the other thing of what you're saying here is you build this foundation of things that you can do, and then as you discover your use cases and what you want to, you know, the kind of applications you want to build around it, you have these components, these building blocks you can use. It's not you've written a reusable architecture, or at least you have the pattern for it, so you don't just have like one duct tape together application that you can't pull apart, but it makes it faster to add new things to it. Well, that's great. I think this is a nice overview. It was fun to learn about it. So, if people wanted to follow up on this stuff, do you have some? Where do you hang out on the World Wide Web, on the internet?
Yeah. So, connect with me on LinkedIn. That's really my go-to social media outlet to connect to folks. And again, I shared that there's a link to this repo on my GitHub. It's basically I'm G Green at GitHub. So yeah, follow me also on GitHub. Let me know what you think about this project, and if you have any questions, you want to pair, or any customers out there have any questions, feel free to reach out to me. I absolutely love doing this stuff, Michael. I'm going to let the hat out the bag. I know this is being recorded. It's going to be shared. I'm the kind of person, I do this stuff like at the pool. Like, so my kids are in the pool, and they're having fun, and I'm coding AI, ML, or data engineering applications using Spring and Rabbit and stuff. I love it.
Having your own fun, just slightly drier.
I love it. Yeah, my wife asked me, "What are you doing?" I said, "I'm having fun, baby."
That's right. I'm solving the meatloaf sentiment problem. We're sorting it out.
Yes.
All right. Well, great. Well, thanks. That was good stuff, and we'll see everyone next time.
All righty. Thank you.